Hey everybody, today we're going to talk about, just going to review solving linear systems algebraically. So there's two different ways to do that. The first we're going to look at is by substitution. Okay, so our first step is going to be solve one of the equations for one of its variables. Then we're going to substitute that expression into the other equation and solve for the other variable. We're going to substitute that value to the first equation and solve it. And then we're going to check the solution in each of the original equations. Now, if you just try to read this and figure out what you're going to do, you're going to have a hard time. Okay, these are your 4 steps. It's actually easier to review them after you've done one. So we'll do this one here. Okay, so let's take this first equation and we'll do the first step. We're going to solve for one of the variables. We're going to solve for y because y is already by itself. So that would be y equals 2x plus 8. Okay, and now we can take that 2x plus 8 and we can substitute it into the second equation. So we get 3x plus y, but y is 2x plus 8, and that equals negative 2. And we're going to solve for our variable x. So we're going to combine our like terms, and we're going to move the 8. And then we're going to divide by 5. And x is going to equal negative 2. Okay, so we've got x is equal to negative 2. We're going to take that number, substitute it back into, I don't know, this one right here. How about it? Doesn't matter which one. One of the two original equations. So we're going to have negative 2 times negative 2 plus y equals 8. So 4 plus y equals 8, which means y is 4. So my answer then is the point negative 2, 4. And I should check that, okay? So I can take negative 2 and plug it in here, and 4 and plug it in here. I get negative 2 times negative 2 is 4, plus 4 is 8. Okay, so that works. 3 times negative 2 is negative 6, plus 4 is negative 2. Winner, winner, chicken dinner. There we go. Okay? So we're good to go there. Now, here's one for you to do, okay? This one's going to be a little bit tougher, but give it a stab and then jump back on, especially if you get confused, and see how it's done. Okay, I'm going to take this first equation, and let's solve for y. So that would be 3y is going to equal negative 2x minus 6. And then I'm going to divide both sides by 3. Remember to divide everything by 3, so y is going to be negative 2/3 x minus 2. Okay, now I'm going to take this right here. This is my y. I'm going to put it into this equation. I cannot put it back in this equation because that's the one I worked on. If I put it in here, everything's going to disappear. It's going to be 0. Okay, so this is going to become 3x plus 2 times negative 2/3 x minus 2 equals 25. And now I'm going to go ahead and distribute the 2 in here. So I get 3x minus 4/3 x minus 4 equals 25. Now I'm going to add 4, and I'm going to combine these like terms. So that's going to be 5/3 x. So 3 would be 9/3, minus 4/3 would be 5/3. That's going to equal 29. And then I'm going to multiply both sides by 3, so 5x is going to be, 2787. And then I'm going to divide by 5. And I'm going to get this nice, ugly answer here, 87/5. Okay, now I can take that and plug it into whichever one of the original equations I want. So I'm going to choose this one because the numbers are smaller. Going back into here. Okay, so that's going to give me 2 times 87/5 plus 3y. It's going to equal negative 6. Okay, so this is going to be what? 274 fifths. Is that right? 87 times 2. 14, 60, 174. Yep. Plus 3y equals -6. Okay, let's turn this into a mixed number. I divide that by 5, I'm going to get 3. It's 15, 24, 34, and 4 fifths. Plus 3y equals -6. Okay, so if I subtract this from both sides, whoops, subtract that from both sides. Wow, this is a horrible problem. Okay, so I'm going to get 3y is going to equal -40 and 4 fifths. Now, it would be convenient to turn that back into a improper fraction, so that'd be -204 fifths. It's going to equal 3y. So I'm going to divide that by 3, which is multiply this by 1/3. Y is going to equal -204 over 15. Okay, so I can reduce that because 3 will go into both of those. 3 is going to go in there 5 times. That's easy. Let's see, 204 divided by 3. That's going to be 68. Okay, so my answer comes out to be 87 fifths and -68 fifths. Wow, that was fun. That is definitely one you should check. I'm going to get out my handy-dandy TI-84 plus C Silver Edition graphing calculator for that. And I'm going to go 3 times, in parentheses, 87 fifths plus 2 times -68 fifths, in parentheses. And that comes out to be 25. How exciting. Okay, now we're going to do the same thing up here. 2 times, in parentheses, 87 fifths plus 3 times -68 fifths, in parentheses, and that's -6. And so that's a big winner right there. Okay, if you can do that one, you can do any one. Okay? Wow. Okay, moving right along. Let's look at elimination, otherwise known as linear combinations. Okay, so the instructions are arrange the equation with like terms in columns. So that means get your x's in the front, your y's next, and then your constants at the end. Obtain coefficients for x or y that differ only in sign by multiplying each term of one or both equations by an appropriate number. Okay, what does that mean? That means I want to get the equations where, let's say, the y is 3y and then the other equation is -3y, or the x is 2x and the other equation is -2x. I want them to be opposites. Add the equations and solve for the remaining variable. Substitute the value obtained in step 3 into either the original equations and solve for the other variable, and check the solution. Okay, let's actually look at this. Okay, here we go. This one, in order to get variables that are opposites, I would either need to get rid of the x's by multiplying the bottom equation by 5 and the top equation by 2, because then I get tens, or I can take the top equation, multiply it by 3, and the bottom equation, multiply it by 4, and then I would get rid of the y's. So we'll go with this. We're going to multiply this by 5 and that by 2. So this becomes 10x plus 8y equals 12. And the bottom becomes -10x minus 15y equals -5. And then I just add those together. Well, the x's go away, and I get -7y equals 7. And so y is -1. Okay, now I finish just like I did the other one. I take this number here, and I plug it into one of the two original equations. How about that one? Okay, so 5x plus 4 times y, but y is negative 1, should equal 6. Okay, so 5x minus 4 equals 6. Add 4 to both sides. 5x is 10, and divide by 5, and x is 2. So I now have my solution. The solution is 2, negative 1. Okay, so let's check it real quick. If I put 2 in there, I get 10 minus 4 equals 6. Okay, that's good. If I put 2 in here, negative 4 plus 3 is negative 1. Okay, so it works. Here's one for you to do. Hopefully it's a little easier than the last one that I had you do. Take a pause on this and give it a try, and then jump back on and see how you did. Okay, so if I'm doing this one, I have my choice of multiplying the top equation by, say, 9 and the bottom equation by negative 2, or I could just multiply the top equation by negative 6, which is a lot less work. So that's what I'm going to do. That's going to give me negative 12x plus 6y equals negative 18. Now, I've got opposites here, so I can combine that. I get negative 3x. Can't seem to write today. Negative 3x, that goes away, equals negative 12. Divide by negative 3, x is 4. Okay? Let's go into the simple equation. We'll go in right here. Okay, so that's going to be 2 times 4 minus y equals 3. 8 minus y equals 3. Y is going to be 5. So my answer then is going to be 4, 5. Okay, so let's test it. 4 in for x, 5 in for y, I get 8 minus 5 is 3. Okay, that works. Put it in here, that's 36 minus 30 is 6. So we got a winner. So hopefully you got that. Okay, we got some special cases. So there are some systems of linear equations where there's no solutions. So if you think about this, the solution is when the lines cross each other, right? So if lines are parallel, they have no solutions because they're never going to intersect. So how do you know if it's parallel? So here's the deal. I look at this and I go, I'm probably going to do this by linear combinations. I'm going to multiply this top equation by 2. So that's going to give me 6x minus 4y equals 10. And I combine it here and I get 0 plus 0. So I get 0 equals 17. Well, that's obviously not true. So anytime all the variables cancel out and you get 0 equals a number, or even if you got two different numbers, 2 equals 5 or something weird like that, that means that those lines are parallel. Okay, this implies the lines are parallel and there are no solutions. And you're done. Okay? Now, what other kind of special cases can you have? Well, here's one. This one's going to have an infinite number of solutions. So what happens with that? Okay, so I look at this one and I go, I think I could multiply this equation by negative 3. So that would give me negative 12x plus 3y equals negative 24. And I combine those and I get, that goes away, so I get 0, and that goes away, so I get 0. So I get 0 equals 0. What that means is these are the same line. Which implies there are infinite solutions. Okay, so if I just had one equation, there's an infinite number of solutions to this. I mean, I could put 1 in here, and I get 4, and then I put -4 here, and I would get 4 plus 4 equals 8. Okay? Well, what if I put 2 in here and 0 here? That'd be 8 minus 0 would equal 8. Okay? And I can just keep doing that. What if I put 5 in here? Well, that would be 20 minus 12 would equal 8. But everything that's going to be a solution to this one is also going to be a solution to this one. So what was it? If I put 2 in here and I put 0 in here, if I put 2 in here, I get 24 minus 0 is 24. Okay? Anything that's a solution to this equation is also a solution to that equation. Okay. And so we're done for the day. I will have a nice little assignment for you. Have a good evening. I'll talk to you guys later.